Hi Geometry, this is a video for our lesson 1-3, which is on reflections and congruency. Yesterday we looked at translations, and I know we're not going to be in class today, but you can watch this video to get information on how you can reflect a geometric object over a line or a point. I have extra help on Friday and Monday of this week. If you have any questions or if you need some clarity on this video, I'm happy to help you. And just know that on Tuesday of next week, and I'll remind you tomorrow, we will have a quiz. It's going to be a quick quiz. We will have a lesson also that day, but you want to make sure you're okay with the content in this video because you can be held responsible for it on the quiz. The way this will work is I want you to listen to the video and follow along in your notes, and you could take notes along with the video just like how you would in class. If you need to hit pause or rewind at any time during the video to rewatch or think through a special part, please feel free to do so as often as you need to. And complete the practice and homework on your own, and don't forget to check the answers on the key online. You can visit my class website, and remember you get there from the About tab on Google Classroom. So we're going to begin. Some prep for the lesson is just knowing how to graph lines. We looked at this in algebra last year. Graphing the line y equals 3. Y is equal to 3, 1, 2, 3, right here on the y-axis, and the line y equals 3 is going to be a horizontal line through that point. So there's your line y equals 3. Facts about it, it's a horizontal line. And the slope here, there is no rise, there is no run, so we say that the slope, remember we use m to notate slope, is equal to 0. To graph the line x equals 2, we're going to go where x is 2 on the x-axis. So I'll change color. X is equal to 2 right here. And the line that makes the most sense to go through that value is going to be a vertical line through that point. So the type of line this is vertical. And the type of slope this has is kind of the flip-flop of 0, but if the denominator is 0, we can say that the slope is undefined. And I forgot a label. I'm going to add that in. X equals 2. To quickly sketch a reflection of triangle ABC and line M, you just want to get it kind of close. So A is approximately like one loop away from line M. So if I'm going to reflect and get its mirror image, I'm going to get the loop about the same amount of size, and I'm going to call that A prime. B is about one loop away as well. So I'm going to repeat that loop going the other way. There's point B prime. See, it looks like it's double the distance. Remember, this is just approximate, it's just a sketch, doesn't have to be perfect here, but I'm going to extend those points. There's my reflected triangle approximately. And we know from the first day of school when we learned about rigid motions that the relationship between triangle ABC and A prime, B prime, C prime is that they are congruent. Because reflections are rigid motions. So that's the big background for this video. If you need to rewatch any of that, please feel free to do that because we have to know what these lines look like. But if you're ready to continue on, we're going to look at what it means to be a reflection. As we prepare to work with reflections, we need to examine some relationships that occur between points and lines when a reflection occurs. Let's take a look at an example of a line reflection. We're going to look at some relationships that occur here. So line M is called the line of reflection. Here's line M right here. That's our line of reflection, LOR. And you can see that point O is called the midpoint, and it's a point directly between P and its image, P prime. So what relationship occurs between the length of PO and P prime O? Well, if it's a midpoint, that means that it's halfway the distance between P and P prime. So the relationship is that they would be equal length. I don't know if you guys noticed this when looking at the diagram, but you see these two markings here between PO and P prime O. That means whenever you see those markings that those segments that have the same little tick mark on them are the same length. What relationship occurs between line M and segment PP prime? If you look closely at the diagram, you'll see this marking right here. That's a right angle marking. So wherever you see that, that shows that line segments are perpendicular to each other. Perpendicular means that they form right angles, and a symbol that we use to show perpendicular is this. It looks like an upside down T. Since line M is perpendicular to segment PP prime and also goes through its midpoint, we would call this line of reflection the perpendicular bisector. Bisector means to cut in half. That's why the piece that talks about why it goes through the midpoint is so important, and the fact that it forms right angles is important for the perpendicular piece. The line of reflection will always be the perpendicular bisector between any point in the pre-image and its corresponding point in the image. So let's take a look more detail about a reflection. So if we're doing a reflection over a line, we know already that is a rigid motion. In which each point in the pre-image has an image that is equidistant or the same distance from the line of reflection, but is on the other side of the line. So it's like it hopped over the line. A reflection in line M maps every point P onto P prime so that line M is the perpendicular bisector of PP prime. There is a special case. So a special vocab word that's going to come up, and we'll see it again in a later unit when we get into more formal proofs, is that if the pre-image point happens to be a point that is on the line of reflection, like you can see right here, point P is on the line we're reflecting over, then the point remains unchanged, or we would say invariant. That means that its location didn't change. If it's on the line of reflection, it's going to stay right in that spot on the line of reflection. And we do have notation for a reflection. We have, whenever we're reflecting something and we want to use a shorthand notation, we use a lowercase r. And that matters. A capital R is for rotation, which we're going to look at another day. So it's a lowercase r, and then some information on the line of reflection that you're reflecting over. A lot of the times they'll just say over the x-axis or the y-axis. Sometimes they'll say reflect over the line y equals 2. So depending on what they say. A lot of times it's going to look something like this. That means reflect over the line y equals 3. Or you might see something like this. Okay? So let's go ahead and try one. We're reflecting over horizontal and vertical lines. In example 1, they want us to graph triangle ABC with vertices A at 1, 3, B 5, 2, and C 2, 1, and its image after the reflection in the line N whose equation is y equals 1. So the first thing you want to do is graph that line. So remember, where is y equal to 1? Well, y is equal to 1 right here, so it has to be a horizontal line through that point, and you're going to draw that line in. There's your line of reflection. Now we're in business, we're ready to go. So what I'm going to do point for point is I'm going to figure out how far each vertex is from the line of reflection. Let's start with point A. So A, as you can see, is 2 units above the line y equals 1. So we can actually fill this quick right in at the same time. Point A is 2 units above line N. So its reflection is going to be 2 units below line N. So I'm going to go 1, 2 down, plot it, A prime. Once you plot it, you also want to state the coordinates on the side, nice and neat. So we have the point 1, negative 1, and we can continue on. Let's look at point B next. B is right here, and it looks like it's 1 unit from the line y equals 1. So it's 1 unit above line N. So its reflection point B prime is going to be 1 unit below line N. So let's copy that distance. Here's line N. We're going to go 1 below right here. There's B prime, and that's the point 1, 2, 3, 4, 5. B prime is the point 5, 0. Last, you can see that C is on the line of reflection. So remember, we talked about that special case. If you're on the line of reflection, you remain invariant. You don't change your position. So C is equal to C prime. And we can just label C prime as the point 2, 1, where it originally started. And then you just want to finish the problem by connecting all the vertices. You can even label this C prime because it is there now. And you have your triangle that's reflected over the line y equals 1. So remember, your tips for success is always graph the line first that you're reflecting over. If you're not doing that, you have to play it by ear, and that's going to get a little sloppy. You don't want to get into a habit of that. The other thing is you always want to make sure you state your coordinates of the final image. This is like your answer if it was on a test. So you want to make sure you connect all the dots before you complete a problem. Let's try one more. We'll try example 2. In example 2, they want us to look at the graph triangle ABC with vertices A at 1, 3, B at 5, 2, C at 2, 1, and its image after the reflection over the line x equals 3. So following the same practice we did in our last example, we're going to have to start by graphing this line x equals 3. That's our line of reflection. It's not always going to straight up tell you what line you're reflecting over. Remember, sometimes you do see this notation. So the reflection over x equals 3 in notation is what that's telling us to do. So let's go ahead and graph that line. X equals 3 right here. And it's going to be a vertical line through that point. It's x equals. So let's go ahead and work on this reflection. We could do a quick write as we go along, starting with point A. Okay, the original A is 1, 2 units left of x equals 3. So A prime would be 2 units right of x equals 3. So let's go ahead and do that. So 2 units left, 2 units right. 1, 2. A prime lands right here. Plot the point and label it for your answer. That's the point 1, 2, 3, 4, 5. 1, 2, 3. Let's do the same work for B prime now. So B is, it's on the other side now, 1, 2 units to the right of the line, x equals 3. So B prime will have to be 2 units left. Just flip-flops over left of x equals 3. So we're going to move 2 units from x equals 3. 1, 2. There's B prime. You want to plot it and we'll state the coordinates for your answer. B prime is the point 1, 2. Our last point to go is point C. You can see that C is 1 unit to the left of the line of reflection. So C is 1 unit left of x equals 3. So C prime is going to have to be 1 unit to the right of x equals 3. So 1 unit to the right of x equals 3 is right here. C prime, you want to plot and label it. That's the point 1, 2, 3, 4, 1, 2, 3, 4, up 1. So C prime is 4, 1. And you can connect the vertices for your final image. It's okay that they're twisted like this. It looks like they overlap in the diagram. Sometimes that happens. They get a little messy, the graphs. But as long as you're showing all your work and you're labeling all your points, you should be in good shape. So what I want you to work on for the rest is to continue working through this packet. We're going to look at special reflections tomorrow. So you want to make sure you have this down because we're going to start combining them in a composition. in our next class, and we're also going to be looking at how you reflect over a point, not a line of reflection. So just make sure you're practicing. You're really going to need this material to be successful in our next class. And if you have any questions, please do not hesitate to ask me at the start of class tomorrow. Please rewatch any part or rewind where necessary. And good luck. I'll see you guys tomorrow. Thank you for watching.